Good afternoon to everyone. Today we discuss about the Fourier series, and before that, myself, Dr. Manoj Mondal, Assistant Professor, Department of Applied Science and Humanities, Haldia Institute of Technology. So we start today the Fourier series of some function, and on the previously we discussed about the Fourier series and full range Fourier series, but today we discuss about the half range Fourier series and where it has the applications of the Fourier series. And for that case, Fourier series and the half range Fourier series. For the half range Fourier series, there will be two types of the half range Fourier series. Number one, this is the sine series, and another one, this is the cosine series. So today we discuss about the half range Fourier sine series. And what actually do the half range Fourier sine series? As like the full range Fourier series, half range sine series also the given functions will be converted into in the terms of the only sine terms will be present there. This is the first thing, and the second thing is that the functions will be infinite sum of the sine terms. Remember here, on the sum terms, there it will be the only sine terms, it will be the present. So what actually the Fourier half range sine series actually do? For the sine series, what will be the construction? How we can construct this half range sine series? For the half range sine series, the functions fx, it will be given the function. That functions will the condition. What is the condition? First thing is that it is defined. It will be the defined in the interval 0 to t, and also it is the integrable. This is the second condition. That means the defined and integrable on the interval 0 to t. If it satisfies this condition, then it is the extended in the domain of the definitions to the minus t to 0. That means our target is that if we consider the functions in such a way that graphical representations, if we provide it, that means originally functions it is 0 to t. That means 0 to t. This is the original portions it is, and suppose the functions be in this way. This is the function from the 0 to t. This is the function. Then we construct the one function in such a way that it satisfies the condition if minus x equal to minus fx. That is, we plot this here on the minus t portion, and it will be in the form of this one. That means 0 to t, the function is here, and minus t to 0, the functions will be in this way. So that means now if I consider the total interval minus t to the interval plus t, the function f of x will be treated as the odd function. Looking upon here on this graph, here this first portion and here another one portion. That means the function f of minus x equal to minus of fx with the definition. That means the functions converted into the form of the odd functions in minus t to plus t. So this is the constructions of the functions. And next, what will be the values of the coefficient? For the constructions of these functions, now in our hand the function fx, which it was defined on the interval 0 to t, now it is defined on the interval minus t to plus t, and the function it is the odd function. Now this is our the Fourier series, in the full range Fourier series. On this full range Fourier series, we know the definition is that a0 is 1 by t minus t to plus t fx dx. This is the value, and for this function's calculations of the a dot, fx be the odd function. Since here the fx be the odd function, then minus t to plus t fx equal to its value always will be the 0. From the property of the integrations we know it. And next one, en, this is the definitions 1 by t minus t to t f of x cos of n by x by t. So similarly here the function fx, this is the odd function, and cos, this function is that the even function. that means the product of the odd function and the even function, that is the odd function. So minus t2 plus t of the odd functions, its value also will be the 0 again. So in our hand, the remaining portion, the bn, what will be the value of the bn here? This bn here, the value of the bn will be this one, 1 by t minus t2 plus t. If of x is the odd function and this is the sine, that means this is also the odd function. So product of the odd function and the odd function, that means this will be the even function. So this is the even function, that bn can be treated in the form of this one, that means 2 by t 0 to t, 2 by t 0 to t fx sine n by x by t dx. This is the bn. That means if we put the value of a0 in the given function here, this function is the f of x, then from here we got a0 equal to 0, an equal to 0 from here, and this bn equal to here. So that means this function can be written as in the form of f of x will be equal to summation bn sine n by x by t, where the value of the bn is nothing but this one. So this is the construction of the half range Fourier sine series. So we can easily construct the one function sine series for the constructions of this one, where this will be the formula fx and this will be the value of the coefficient bn. So if we put this coefficient here, we can easily find out the. So next we consider the one example. What will be the example? Example will be, suppose for the sine series we consider here the one example. Find the Fourier sine series of the function fx, fx equal to pi minus x in the interval 0 to pi. So for finding out the half range Fourier sine series, so we know the formula, the sine series, this f of x equal to, this one be the sine series bn sine n by x by t, and looking upon here the interval is that the 0 to pi. So this is the half range interval 0 to pi. So for here we have to at first find out the bn. So what will be the bn? The value of bn, that will be here, this is the definition, that means 2 by pi 0 to pi, 0 to pi, why? Because 0 to pi, this is the limit. F of x means pi minus x, this one, into sine n pi x by pi, this one, and dx. So this pi cancel, that means only sine x. So if I just calculate for the integrations, so this one, so it will be the pi minus x first function, next here integrating by parts, sine nx integration minus of cos nx by n minus derivative of this portion, that is the minus 1, and integrations of the second portions, that means minus of sine nx divided by n, and again another integration, that is the n square. So this will be integration 0 to pi. This is the limit. So now if we put the upper limit and the lower limit for both the cases, this portion sine nx, so this part also will be the always provide this value equal to 0, and if we put on here for the upper limit x equal to pi, that also will be the 0, and only we have to find out the value for the lower part, that means the lower limit, that means 2 by pi for x equal to 0, that means it will be the pi into 1 by n. So that means equal to pi cancel, so it will be 2 by n. That will be the value of the bn. So now easily we can find out what is the value of the bn. So therefore from here we can easily find out what will be the Fourier series, half range Fourier series. It will be just put the value of bn here, that means summation bn, the value of bn, that is the 2 by n sine nx. because why? N pi x by t, actually n pi x by pi, so pi cancel, so only the nx, so here its value will be the only. So this is the summation, and n equal to 1 to infinity. So this will be the required half range Fourier sine series. So next one, by applying this one, hence we have to prove this one, and hence so that this one. So for that case, so this is our the Fourier half range sine series. So now we have to choose the value of x in such a way that when we put here, we can easily find out this value. So this is in our the Fourier half range sine series, whatever already we do in our the previous slide. Here, this is actually the fx. Here, this is the fx. Fx means this is the pi minus x. That one equal to this series. So this is nothing but from here. So pi minus x equal to that one. Now, if I put x equal to pi by 2 on both sides, then from here, what actually we have? So pi minus pi by 2, and that's equal to 2 into this one. So what actually we got here? When we put x equal to pi by 2, sine pi by 2, that's equal to 1. Next, plus sine 2 pi by 2, sine 2 pi by 2, that means sine pi, that's equal to 0. And sine next one plus sine 3 pi by 2, 3 pi by 2, that means the minus 1. Here 2, and here this is the minus 1 divided by 3, this one, and next here it is the 0, and again it is the plus 1 by 5 and minus 1 in this way. So that means from here the left hand side it will be the pi by 2 left hand side, and the right hand side 2 into 1 minus 1 by 3, this portion, that is plus 1 by 5 minus 1 by 7 plus. So if we take this 2 on this side, so that means we got here pi by 4, that is nothing but 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 and plus. So this will be the required result. That means we can easily do this portion here. Hence, so this is the first problem. Now we continue with the another one problem, the second problem. So another one sine series. This one, suppose we consider the another one example, fx equal to 1. That fx equal to 1 defined on the interval 0 to pi, and when you consider defined on that interval, similarly this will be the our series, that is the fx equal to this series, and bn, we have to find out the function value of bn. This is bn. This is the definitions of the bn. 2 by pi. Here the interval 0 to pi, so 2 by pi, that one, and integration 0 to pi, fx is that 1, and sine nx, because n pi x by pi, it will cancel again, n pi x by pi, so this pi cancel, so it will be sine nx. For that result, this is the sine nx. So when I do the integration by pi to pi, sine nx integration minus of cos nx by n 0 to pi, this one, and when we put the limit, its value will be equal to 2 by pi, and for the upper limit minus of cos n pi minus 1 to the power n cos n pi by n, and for the lower limit, that is 1 by n, cos 0 equal to 1 by n, this one. And for this case, if we consider n is the even and n is the odd, when n is the odd, then what happened? N equal to odd, that means it will be minus 1 to the power n odd, that is the minus 1, and minus 1 plus 1, that will be that 4 pi. Here this is a 1 and here another 1, so that means 2 into 2 4 into 4 4 divided by n pi for n odd. And when n even, so minus 1 to the power n, that is the even number, even 1, that means plus 1, and minus 1, that will be the 0, that means 0 when n even. So this is our the Bn. Now we put Bn on the given series, that means the series f of x equal to, this is the series summation Bn sin n pi x by t, that means put the value summation n equal to 1 to infinity Bn only here it is the odd value, so we consider here the only odd value, that is the summation n is odd only, n is odd, n value 4 by n pi, 4 by n pi, this is the Bn and sin x. This is the Fourier half range sine series of the function, and fx equal to left hand side 1, so that means 1 equal to fx equal to 1 plus even fx equal to 1, so 1 equal to this series. So this is the required half range sine series of the given function fx equal to 1. Now with the help of that things we have to prove that this line again. So what actually we have to do? For the next thing we have to choose x equal to something. This is our the half range Fourier sine series, whatever already we proved in our the previous slide. Now we have to put x equal to something so that we can find out this result. So if we put here x equal to pi by 2, then what happened? So x equal to 1, this one, and 4 by pi, and here sine pi by 2, that is the 1, sine 3 pi by 2, that is the minus 1, that means minus 1 by 3, sine 5 pi by 2, that means plus 1 divided by 5, and next one similarly we get 1 by 7 and plus this one. So that means if I take this constant on the this side, so it is the pi by 4, that's equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus this one. So this will be the proof. That means what actually we got here. So that means easily we can find out the half range Fourier sine series if we just find out only the value of the b of that functions with this formula, then put here that will be the pure series, just put here the b, we can easily find out the Fourier series, and with the help of the values of x in such way this one, we can prove any kind of the series here, that type of series. And so thank you for today.